look at a couple of problems here in section 3.7 dealing with the chain rule. And in these, notation I could see as a problem as much as the chain rule in and of itself in this section. So they're wanting us to take the third derivative of this polynomial 14 minus 2x raised to the sixth power. Well, you know you can't just magically take the third derivative without taking the derivative one step at a time. So if I'm using correct notation, when I take the derivative once, I still need to show that that derivative needs to be taken two more times. So I say, well, the third derivative is equal to the second derivative of the derivative of this function. So I can say, well, the 6 came down in front, times the group to the fifth power, times the derivative of the inside. Again, that's because of the chain rule. I simplified this to be negative 12 times the group 14 minus 2x to the fifth. Now, I still need to take the derivative two more times. Well, I can say that, and then that's equal to d dx. This is telling me I need to take the derivative one more time of the expression, that's the derivative of this expression, which would give me 5 times negative 12 is negative 60, times our group to the fourth, times the derivative of the inside again, which is negative 2. Now I know negative 60 times negative 2 is going to be a positive 120 here, times the group to the fourth power. Now I still need to take the derivative one last time. 4 times 120 is 480, times the group to the third, times the derivative of the inside, negative 2, should give us a negative 960 times this group to the third power, negative 960 times the group 14 minus 2x. And we know that that group is raised to the third power. We'll check this answer. And correct. The first time I accidentally left off the negative. If you're saying, hey, you solved it in 2 attempts, I just forgot the negative in the first attempt. For the next problem, for 23, you'll see it's a very similar problem. It's wanting us to take the derivative 3 times of the expression 2 sine of 3x. Again, I'm just as interested in your ability to show notationally how to work this problem correctly as I am the final answer. We say, well, the derivative, the third derivative of 2 sine of 3x is equal to the second derivative of this function. Derivative of sine is cosine times the derivative of the angle 3. So you can say this is just going to be the second derivative of 6 cosine of 3x. Now I take the derivative one more time and still say, well, then this is equal to the first derivative of cosine is negative sine, so this is going to be negative 6 sine of 3x times the derivative of the angle 3. I'll get negative 18 sine of 3x, and again show I have to take the derivative one more time. So that differential operator d dx tells me you need to take the derivative again. Derivative of sine is cosine. I'll get derivative of negative 18 sine is negative 18 cosine of the angle 3x times the derivative of the angle 3. Whenever I multiply that out, of course, 18 times negative 3 should be negative 54. I try that, negative 54 cosine, and then our angle is 3x. I'll close that off and check it, and it's saying correct. Okay, guys, hope this helped out with these two problems. I don't think that the derivative process was all that bad, but please do make sure you see notationally every time I took the derivative one time, I still had to have the operator here. In this case, I needed to take the derivative 2 more times. In this one, I still needed to take the derivative 1 more time. After you took that derivative 3 times, of course, we can put our final answer, and that d dx must disappear. So many students have a horrible habit of saying d dx is equal to something. d dx can never equal anything. It's just an operator. Okay, guys, hope that this helped with this section. Let me know if you have any other questions. Be glad to help.